Hello everyone. Now we're going to present how Apache Ozone builds up high availability with Raft protocol. This is Li Cheng. I'm currently senior engineer at Tencent. Also, I'm Hadoop committer and Ozone PMC. We will have other two engineers who join us for presenting this talk. Nanda from Cloudera. He is currently Hadoop PMC and Ozone PMC. Also, we have Shashik from Cloudera. He is currently Hadoop PMC, Ozone PMC, and Apache Ratis PMC. Now, firstly, we're going to introduce what is Apache Ozone. Apache Ozone is a distributed key value store designed to scale to billions of projects and run on clusters of thousands of nodes. Ozone supports RPC and S3 APIs as well as Hadoop compatible file system called Ozone FS. Hadoop Ozone is originally from Hadoop community and has become Apache top level project in 2020. And Ozone is now heavily used in production in Tencent. Now we're going to look at Ozone's overall architecture. Ozone has two metadata manager, Ozone Manager and Storage Container Manager. Ozone Manager is managing a lot of control plane metadata, such as block info and file info. Storage Container Manager is going to manage all the nodes on the data nodes health, heartbeats, and health reports. We also have data nodes for writing data and storing data, which is similar to what HDFS data nodes does. So Ozone's motivation is to resolve some of the challenges from HDFS. For HDFS use case, name node has scalability concerns, and there are a lot of file operation concurrency which could cause problem or stuck. And HDFS also handles reports in name node as well, so there is heavily burden on the memory side. And the name node is very slow to start up, especially for large clusters. So Ozone's motivation is to scale both namespace and block layer, also to scaling to trillions of objects, and we'll do a lot of optimization, especially for small files, which namespace has difficulties handling with. We also want to build a pretty versatile storage solution to use. So Ozone has a lot of basically a lot of use case in either EMR or Kubernetes. So there are many more deployment methods around Ozone which can make EMR users or Kubernetes users pretty easy to deploy Ozone cluster. We just talked about Ozone Manager and the Storage Container Manager. Now we're going to let you know why we are so centric on the HA part. So this is basically Ozone's write process and read process. So client will send the request to Ozone Manager, and Ozone Manager will will basically put a lot of block operations, container operations, and pipeline operations to SCM. And SCM also is responsible for handling container report, pipeline report, and node report from data nodes. So Ozone has already implemented Ozone Manager HA and the SCM HA in order to make the cluster more robust to handle a lot of operations or very high concurrency. Also, when a single OM or SCM is down, the cluster is easy to recover and still be able to handle the high concurrency requests. So this is pretty much why we're so centric in implementing Ozone HA in 2020 and 2021. So Ozone HA's goals is first for fast failover process in Ozone. Second, we need HA to have strong consistency, especially around metadata area. Third, we need to have transparent failover for the entire Ozone clusters. Now we'll have Shashik to introduce Apache Ratis, where we use Apache Ratis for implementing Ozone HA overall.
So let's now talk about Apache Ratis and the basic ideas behind Apache Ratis and how it is being used for Apache Ozone. So Apache Ratis is an implementation of Raft consensus algorithm. It's an open source Java library, very actively being developed in the Apache community right now. So any of you, your friends or colleagues have an interest in it and want to contribute, please feel free to do that. Any sort of contribution is welcome and really appreciated. So typically, a Ratis cluster will have a leader, and so leader will be elected out of a quorum of nodes, and the other. So one guy will be the leader, other will become followers. Leader will basically be the central authority. Clients will send all the requests to the leader, and then leader will basically validate the request and create the transactions, and the same sort of transactions are replicated over to the followers. So let's talk about some Raft basics. Typically, you will have a leader election mechanism where all the servers, when they start, they'll start as a follower. Then randomly, they'll become a candidate and start a leader election mechanism where each of the candidates will become a candidate. After becoming candidate, will basically send out a request vote, and once a node gets majority of the votes, will become a leader, and other becomes followers. So, and I mean the next mechanism is it's called append interest mechanism, where typically what happens is when the client sends any request to the leader will intercept that, validate the request, and then basically creates a log transaction, and it sends out the same sort of a request to the followers by a mechanism called append entry mechanism. So leader sends the append entry to the followers acknowledge the append entry request from the leader, and in cases where there are no client requests coming, so leader sends out empty append entry request to the followers. This becomes a means of hard beating among the nodes in the cluster. So, and this is how essentially they maintain a leader forward relationship among the nodes of the cluster. So these are the basic standard Raft features we have. We have a redirection mechanism, so every node can become a candidate and start a redirection on a randomized time, and each of the redirection basically each of the redirection event times out at a random interval on each of the nodes. So there are no chances of having a split votes or multiple leaders getting elected at the same time. So once a election is done, the leader basically accepts all the uh, client request, creates log transactions, and the same log is replicated to all the nodes in the servers. These servers will basically form a group called a Ratis group, which is defined by a Raft group ID. So in any point of time, there's one leader of a Raft group and others are followers. It supports membership changes, so you can basically reconfigure your cluster at runtime. You can bump up the priority of certain nodes. You can basically add a node, remove a node. The replication factor in terms of the number of participating nodes can be changed at runtime without any downtime. And also has a log compaction feature. So typically you don't need to maintain the history of logs right from the beginning. A snapshot can be triggered periodically, which will basically keeps a point in time copy, and then every time when a node is added, it basically can send out a um, can basically send out a request to catch up with the other nodes in the cluster. So leader can basically send out the complete snapshot of the the history of transaction which it has in terms of a single snapshot file. It doesn't need to basically send out a complete long log history to the newly added nodes. That is, as we discussed, it's very pluggable. It's a Java library. Any services which or any sort of application which needs to use Ratis can load it as a library. It is a pluggable state machine model where Typically, applications can define their state machine according to their own conveniences. Uh, there's a very basic example of a key value map, and also there is an example of a file store in Apache Ratis. So to basically you can just go and try out that, and we'll see what sort of features Ratis brings into the table. It has a pluggable RPC model. User can provide their own RPC implementation. Um, I mean, default implementations are done in gRPC, native in Hadoop RPC, where gRPC gives you the complete implementation of a native client, and this is what is being used in Apache Ozone for metadata and data application right now. And then it has a pluggable Raft log model where applications again can define their own log implementation. The default implementation is that where it stores the log files in the local file system. So let's talk about the Apache Ratis use cases now. So typically what happens is whenever there is a need to replicate the server state or mutations or the logs to multiple machines, you can very well use Ratis there. Uh, so the application number, the cluster membership can be reconfigured at any point of time dynamically without having to bring down the cluster. And there is automatic redirection that is happening. You can basically tolerate node failures depending on how you configure the cluster. So at any point of time, if majority of the nodes are alive in the cluster can keep on continue its business as usual with tolerating all sorts of other failures like network or node going down or network partitions happening. All sorts of failures are basically being handled on Apache Ratis. So at any point of time, if the number of quorum nodes are alive and hard beating to each other, the clusters of the applications and keep on continuing working. Or if you need a highly available service, so typically when a server falls, you need other servers to take up the charge and sort of this and basically continue on the business. Apache Ratis is just for you. It can automatically does the leader election without any manual intervention, as I told you. So unless and until the quorum number of nodes, minimum quorum number of nodes are alive and hard beating to each other, it can keep on working. And there's a Raft client which basically does an automatic failover to the right leader. So if you use that, you can very seamlessly keep on working. So these are the typical use cases which Apache Ratis has, and from now on, my colleague Nanda will take on, where he will describe about how Apache Ratis is being used internally in Ozone HA architecture overall for Ozone Manager and storage container manager. Over to you, Nanda. Thank you. Thank you very much.